if more brave hearts will join us. So my name is Nelly Porter. I am part of OS security team and its enterprise and security team, part of bigger OS group. My team is responsible for multiple areas, in particular user and device authentication, PKI, public key infrastructure, and crypto. Today, we'll be talking about a very specific area, and this area is very, very important to us. We've been working on this topic not 1 or 2 years for quite some time. And probably some of you that were deploying Windows 8, 8.1 seen virtual smart cards and smart cards that we delivered. So we realized that without convenience, there is no solution with security. And security needs to be incredibly convenient, so people will not have to deal with security as is. So we need to hide it as much as possible from normal human beings' eyes and hands, so they don't need to remember a lot of things or trying to configure a lot of things. So I will not try to convince you that passwords are bad. I think it's not the audience that I need to spend too much time on that. But this number is very interesting. How many of you know plus minus? I don't need to the decimal point. How many people today online? Any number will do. 2. Cool. Good. Not correct, but I'm talking about worldwide, on the whole entire planet. And not only today, but again, people that actually using internet for whatever purposes. I will not go into this topic today. Okay, so any number.
1 million.
Come on, anything. So we're talking about more than 2 billion people. More than 2 billion people online today. And with Russian hackers stealing 1.2 billion, you can do math in your heads, is almost every second one is actually password is stolen. Again, the legitimacy of this attack is questionable, but still they have millions and millions of user passwords. And because passwords are so difficult to remember, I know we're all quite aware of that, and users trying everything possible to reuse the same passwords. By the way, do you know that our brains are capable to remember only 5 plus minus 2 numbers? It's why your phone number is not more than 7 numbers. So any strong password that we recommend our users to use is around 10, 8, 10, with some numbers, uppercase, lowercase, special symbols. So when poor human beings are actually capable to remember those passwords, they're trying to reuse it where it's possible, and the problem is starting to hit us big deal. I'm talking about 3 properties of the passwords that we hate the most. The first one, it's symmetrical secret. Any secret, when it's symmetrical, is a problem. If I know my password and my server or my, what I will call identity provider, entity that authenticating me knows my password, then by hacking or breaching servers, we can get every single password that this server is trying to protect. And after that, those passwords can be replayed against much more secure and protected enterprises because users are using the same passwords. So breach or breachability is one of the biggest issues that we are trying to address. Second one, password is software secret. What I mean by that when it's software, it means system-level malware can lift this password from your box and replay it everywhere else. As a result of that, users and their accounts can be easily compromised. The third one is a phish attack. And the problem is also on our side as well. We train our users when they see something that look like password box, smell like password box, quack like password box. They're sharing their credentials, no questions asked. And as a result of that, their credentials easily phished and can be replayed anywhere else. So those three problems, breach, replay, and phish, is what Microsoft Passport is trying to address. Our goal is not a password replacement. Our goal is, let me start again. Our goal is actually do not augment passwords. We don't want to add additional factors, second factor, third factor, or fifth factor to existing network symmetric secret. What we want to do, we want to replace passwords with something that's much more convenient for users and much more secure. So we're replacing Microsoft Passport is providing what we call public-private key pair. And this public-private key pair is generated on the client and associated with every single user. We also add what we call user gesture on top of those keys, so we would be able to validate that user present when user providing this gesture. Those gestures can be PIN or biometrics, Windows Hello. We're going to ship in Windows 10 two different flavors of Microsoft Passport. One of them is when users will provision, or we will provision on behalf of the users, those local keys on the local device. And we will collect this gesture from the user on the same local device. So by utilizing those public-private key pair, we would be able to access remote services and unlock the device itself. However, we're planning to also ship one additional flavor of Microsoft Passport. We talk about Passport to Go. And the idea is that if you have your mobile devices, say I have my phone, where is my phone? I have my phone, and I will provision my Microsoft Passport right there in the phone. So then, from phone, I would be able to access all remote services and all things that I need to access, strongly authenticating myself. But it's not enough. We want to use this phone as a remote authenticator when you're accessing any other devices that user trying to access. This scenario, we believe, will help with communal devices, when users are not assigned to the same device, and they cannot provision those keys on this device. So then they can take their phone or any other wearable device and will authenticate across multiple other PCs, laptops, and desktops that they want to authenticate to without sharing any credentials. From consumer side, we see this scenario very, very compelling when my friends coming to my house and trying to play multiplayer with me on Xbox. Today they need to authenticate to my Xbox and leaving all traces behind. Tomorrow they don't need to do it. They will take the phone out of their pockets, they type the PIN or touch sensor on this phone, look at the camera, smile, and by doing so, they would be able to authenticate to Xbox Live, and play multiplayer game with me without, again, sharing anything on my device. And the goal for us, the third and the most important goal, actually, is to make Microsoft Passport so convenient and so easy to use, then without introduction, any additional friction. Then with this capability, users would use it, love it, feel very, very actually special when they utilize this capability. We want to be personal, we want to be very, very entertaining, and Windows Hello will help us with that. Okay, so from IT perspective, we will support both. We will support two flavors. We called it Key Trust and Third Trust. It means we will provision for Microsoft Passport the public-private key pair, as I mentioned, RSA 2040A bit keys, and also certificates associated with those keys. So if your organization is actually love PKI, by the way, how many of you have today public key infrastructure scenarios like VPN? That's what I guessed. Thank you so much. Okay, and how many of you never done PKI, will never do PKI, whatever we will do for you, however we will bribe you? Any questions? Any hands? No? You will do that. Okay. Okay, so for those of you who have PKI and need to do PKI, Microsoft Passport will support PKI-based scenario as well. It means you would be able to enroll certificate with Microsoft Passport and use it for every single scenario that you used before. For user, it will be very simple, very familiar. They would use their biometrics. It can be face, iris, or fingerprint, or as fallback PIN. So PIN is incredibly important for us. PIN is not password, and PIN is not password because it's local. It's not your network cred. As a result of that, PIN can be, again, actually a little simpler and don't need to change very often. And because we brute force protect this PIN with TPMs, something I will talk a little later, you can actually relax your policy and make it a little simpler. When we provision Microsoft Passport, it's very critical, and I will repeat again and again, to have proofable solution because the strength of your credentials is very much related to the strength of proofing method that you used when you generated these credentials. Out of the box, Azure Active Directory and AD with ADFS 10, will provide multiple proofing methods for us to be able to provision Microsoft Passport. And it can be OTP, OTC, phone factor. It also have support for third-party proofing methods. You can proof Microsoft Passport with smart cards if you use smart cards, or if you use any other authentication method to prove those credentials, you can do that. And by the end of the day, as simple as it sounds, the public key of this public-private key pair is sent to the server and associated with user account. And then server, when it needs to authenticate the user, and again, the secret that I want to share with you is that any authentication protocol is actually very similar. It doesn't matter if it's Kerberos, if it's SAML, if it's OAuth. By the end of the day, server is sending some challenge to the client, and client needs to sign this challenge with a private key. And if server is in possession of public key, it can validate the signature, and by virtue of validating signature, it's deciding that user is authenticated. Next point. We will generate those keys on TPM, but don't take my word for that. If we will find any TPM for enterprises being 1.2 or 2.0, discrete or firmware, we will generate those keys on TPMs. However, long time ago, I think in 2008, or maybe it was 2012 R2, servers, ADCS, certificate services server, can tell client, go and generate those keys for these particular certificates in TPM. And client, very trustworthy client, will say, yes, sir, and never can be proven right or wrong. It is really why we believe that critically important for us, yet additional capability of Microsoft Passport. We called it ability to attest that we actually did what server asked us to do. This attestation is done based on TCG, it's Trusted Computing Group's specs for TPMs. And it's quite interesting process. I will not, again, bother you explaining the protocol, but the idea is every TPM has a root trust. We called it endorsement key certificate. And every TPM 2.0 must have this cert. This certificate is infused into TPM when TPM is created. And then to ensure that we will not track user across multiple identity providers, Microsoft have spawned service online, Microsoft CA service, that for every single Windows 10 devices for Microsoft Passport, they're issuing attestation certificate for every tenant that this client would be able to talk to. And this attestation certificate we're presenting together with public key to the server, and it's cryptographically proving the fact that we generated those keys in TPM. It's so important that our servers, Active Directory, Azure Active Directory, and even our consumer first-party servers, Microsoft account, taking notice of this attestation statement. And if attestation statement is present, they know that we are not lying. They know that those keys are really in TPM, and based on that, they're making different access policy decisions. The tokens that they generated is short-lived or longer-lived, depending on the fact that those keys are tested or not. If you have any questions, I can go on and on and on about this topic, but let's leave it to the side. From user perspective, user only unlocks the device, and by providing the gesture, they give us access to those keys. The keys, because they're in TPM, by the way, TPM or Trusted Platform Module provides beautiful property for us, really cool property. TPMs is crypto processor, and this crypto processor allow us to run cryptographic operations like sign or decrypt in isolated environment of TPM hardware or firmware. As a result of that, we will be able to sign with Microsoft Passport private key those authentication claims and send it to our server in isolation of TPM. It means system-level malware would not be able to intervene in our communication with the server. In addition, the bonus things that TPMs provide for us is beautiful brute force protection. Brute force protection is ability for us to help users with simpler pins. Because what TPMs do, and the same with biometrics, Windows Hello, they help us to ensure that user would not have ability to provide multiple times wrong pins. Every single time, actually 5 times, we're slowing user down, and after 32 times of typing wrong pin or using wrong finger on their devices, the TPM will be locked, and admin help is required to unlock this device. And to ensure that every single scenario is available, we're also working to provide browser support with Microsoft Passport, creation of the keys, creation of the certificate, and usage of those certificates. So one more additional word on that. We absolutely well aware that Microsoft alone would not be able to address this problem. And that's really why we joined in December 2014 the group called Fast Identity Online Alliance. This group is a very interesting group. It's a lot of companies. It's more than 190 companies today. They're trying to address the same problem. And because it's so aligned with our goal, we strongly believe that together, standardizing what I'm talking about, we would be able to accomplish our goal. We submitted what we called FIDO 2 specs to FIDO, and FIDO 2 specs are implemented as part of Microsoft Passport. And the technology that I'm talking about is the first reference implementation of those specs. So let me walk you through the process. And I know that it's going to be a little more complex, but let me go slowly. So we have user, and we have identity provider. And identity provider is any entity that authenticating user. Any entity that asking me, please provide me username and password, and I will let you access some resources. When we're talking about resources, we are talking about access to, again, OneDrive, or access to SharePoint, or access to anything else that user is trying to access to be productive. From identity providers that will support Microsoft Passport, we are talking about all first-party identity providers. It's Active Directory, Azure Active Directory, it's our consumer identity provider, MSA, Microsoft account, and also we're talking to multiple third-party identity providers that planning to utilize FIDO 2 specs to ensure strong user authentication with Microsoft Passport. So what is happening? User is creating account, or user already has account and wants to change this account from using passwords to something stronger like Microsoft Passport. To do that, identity provider will ask user to prove themselves. And proofing method is very, very important. So let me tell you a quick story. In Microsoft, when we're receiving smart card, we need to do in-person proofing. Some companies have this requirement as well. We have special building in Microsoft when you need to show yourself with your documents, your passport, your all other documents that you have, and only after that you will get your smart card that you would be able to unlock and get access to certificates on smart card. So it's the strongest proofing method that can be done. Unfortunately, not every company would be able to do that. So some companies relying on derived proofing methods or digital proofing methods. Okay, so let's assume that user proof himself or herself very nicely. Now what happened? We will register and create the keys for this user. If it's certificate-based, we will enroll certificate right there for the user. And we will take the public key of this key pair and send it during registration to identity provider. Identity provider will validate the attestation claim or lack of attestation claim, will take the public key, associate it with user account, and from now on it would be able to challenge client or user to authenticate them. As I said, authentication is by the end of the day sending challenge, being timestamped, nonce, whatever protocols will throw at us. And what we will do, we'll take the private key in TPM after user allow us to get access to this private key by smiling at the camera or touching fingerprint sensor, whatever they like, they have choice. Or if no biometrics available, they can do it by typing the PIN. And by doing so, we're signing this authentication challenge coming from identity provider and sending this back to AD or Azure Active Directory or Microsoft account. As a result of that, the signature is validated, the user is authenticated, and then the interesting thing happening. Usually, identity provider is creating authentication token. Some of you ask about pass the hash attack. Here, the pass the hash attack is started. After I strongly authenticated and issued for this user token, now if this token is stolen and replayed, whatever we've done with Microsoft Passport is absolutely useless, literally useless. So working with community, we submitted to IETF proposal that called token binding. It's co-authored proposal between us, Microsoft, and Google. They're trying to address exactly this problem. What I'm talking about, this authentication token will be tied to the device as well. So nobody would be able to steal the token, authentication token, and replay it from other devices. So it's what we're trying to accomplish, so we don't need to run after NTLM hashes and trying to protect them after all with pass the hash attack. After this particular token is issued, this token can issue different type of token. We called it OZ token or access token. And those tokens can be issued to give me finally permission to get access to my spec in SharePoint or being able to get my pictures from my OneDrive. So the completed cycle started from user is actually touching the sensor or unlocking their device and finishing with me getting access to what I wanted. Any questions so far? Okay. Yes, please.
What happens when the device gets stolen or something like that and into a file?
So when device is stolen, and it's why two-factor authentication is what we're coming with, attacker would need, in addition to the device, have ability to spoof my biometric identity or have my PIN to be able to access those particular credentials. However, again, if they will try to type this PIN wrongly multiple times, we called it offline attack, the TPM will lock and protect us with TPM brute force attack. However, if the keys are created in software, this protection is limited. And absolutely, out of the three properties that I talked about, breach, no replay and fish. No replay is in the toilet. We don't have no replay protection. So simply to give you perspective. And you as IT, and I will show you the policy, would be able to control what type of credentials we create for the users. If it's allowed for us to create hardware and fall back to software if hardware is not present, or simply fail or do not create the keys in the first place. So this diagram is trying to explain you what is happening behind the curtain. We're creating two containers, and those containers protected with what we call authenticators. And those authenticators or user gestures, it's what we do all the time. So we have those two containers that you will find on any Windows 10 devices. One of them, we call the default container. And it's created right there in out of UBI experience when user will say, here's my Microsoft account, if it's consumer PC or personal device, and here are my credentials, username and password. And after that, we will indice user to create their PIN or enroll biometrics. And as soon as user will go and create the PIN, we will create this default container. This default container is very important for us because it's not only Microsoft account keys will be generated there. Any third-party identity provider being, again, I can name a few names, when they need to protect their own users can generate keys in the same default container. And very important properties that we will offer all of them. Their keys will be fully isolated, and user, it's privacy, 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 would not be tracked only because they have access to multiple identity providers. We also have separate container. It means we have separate gesture. It's what we call work pin. And this work pin is opening enterprise container. So it was huge amount of discussion inside of my teams and multiple teams. Do we want to have separate gestures, single gesture, name it? The problem is, again, combining everything, your personal life and your enterprise life is mingled, and it's not something that we want to provide moving forward. So what we want to have is that your enterprise container will have whatever policy you, ITs of your organization will decide to apply. So we have different policy for enterprise container that can be managed utilizing MDM. Our first-party MDM Intune would have full support of pushing policy to those enterprise containers or enterprise-based devices. The same with third-party MDMs. If you have any questions about that, we have sessions or had sessions about MDM support, and MDMs would be able to push those policies. Let me switch and show you what policy we're talking about. And covering the camera, sorry, is important thing for us because it will recognize us too quickly. So I will go with GP edit. And you can't see anything. I see. Okay, so let me go with 2. Sorry for that. Looks better? Okay, so with GP edit, let me show you what policy we actually enable. So you will find those policy in your normal place where you would expect those policy to have. And it's device-wide policy. And you will find them under Microsoft Passport for Work. So we didn't expose too many policies, trying to not confuse you too much. But there are policies that are very important. So this one is a big red switch. We'll say, enable Microsoft Passport for those devices or not. And this switch is critically important because you need to set up your backend before we will enable Microsoft Passport on the client. And this switch is actually, if it's not configured, it's going to be on by default. So use biometrics is ability for you to apply biometrics gesture or disallow using biometric gesture as Microsoft Passport component. This use hardware security device, this policy is very important. This policy will tell you if you would be able to force us only and only use hardware. So if we have TPMs, as I said, TPM 1.2, TPM 2.0 for enterprises, we will create those keys or enroll certificates. If it's not possible, we will all fail or will fall back to software. This is the policy that will control it. And plenty of the policy to control PIN. I know that we all love to control PIN. My Microsoft IT is actually very happy that we have plenty of those policies. We have everything for you. My only and only ask, if it's possible, think about brute force protections that we have and don't go absolutely crazy on those policies. Okay, so it's about policies. Let me switch back to my PowerPoint. And we will go to the second topic. So Passport to Go. Passport to Go, as I said, it's ability for us to provision those keys in those containers that you already know on local device, but use those keys. Yes, please, sorry. Absolutely, thank you so much. So the question is, what you've shown us is local policy. Is it possible to enforce through GP, GPO, MDM, SCCM, name whatever management tool you have? Yes, all of those policies, exactly the same policy, can be enforced through all of those different management solutions. It's just Windows 10. And we loved, by the way, in Windows, because we supported biometrics in Windows 7 and Windows 8. We have some biometric policy. We left them untouched. So again, if you continue to enforce them, they will apply to Windows 8, Windows 7 machines as well. Yes, please.
Can the back-end identity provider store more than one public key so that I can get passport authentication on more than one device?
It's design. It's designed exactly like you described. So the question is if identity providers, servers, can store more than one public key associated with the user. The idea is it's absolutely by design, we support that. As more devices you will have, as more keys we will generate for those devices, and as more public keys, I hope we will not go absolutely crazy with that, we will store and we will preserve on our servers, AD, etc. And by the way, if the user is actually living organization, it's a very easy way to break the relationship between user and your organization by deleting the public key. As soon as you deleted public key on your server, you will have all what you need. It means user would not be able to authenticate anymore to your premises. So, yes, please. So, very good question. So the question is, do we support multi-user identity on the same devices or multiple devices? And we absolutely do, because Windows is multi-user system. So if you have admin or multiple users on the same box, we will provision those keys and containers for every single user. Those containers is per user, per device. Thank you so much. Very good question. So, pass. Yes, please.
How large is it?
Hmm?
How large? How big are the
RSA 2048 bit. 2048 bit. It depends on how many, again, devices per how many users you will have. Again, we very big organization, Microsoft, and we enable it and we handle it quite nicely. So I think it's not a big problem. But good question. I don't know if storage is actually problematic for you. But okay, Switching a little bit topic, let's talk about Passport to Go. To explain you the concept, I think the concept is understood more or less, but simply, again, we decided to create a video. By the way, my disclaimer, this video is created by my PM team, so absolutely not marketing, quality is not the best, but we're trying to show you how we see and what we want to do with Passport to Go.
With Remote NGC, your phone's presence can be used as a second factor of authentication, meaning when your phone's around, you'll be able to log in just fine. And if your phone's not around, moved somewhere away from your PC, your device is safe from attackers, even if they know your PIN.
Okay, to sum it up. The idea is that we will have the phone. And again, we're talking about Windows Phone and Android phone and iOS phone. So we want to be able to authenticate users from those devices, mobile devices, to any other devices that they actually working day and night. Sometimes, if the device is assigned to user, you need to provision those keys on the device. But sometimes, like help desk scenario, or manufacture floor, or any other communal devices, you don't want to provision those keys on those devices. So to be able to authenticate users, we're presenting this phone as a smart card per se. And this ability for us not only to unlock this device, but also because we have certificates on this phone, we would be able to provide access to VPN, SMIME, secure browsing, any scenarios that certificates would support today. So you would be able to use it whenever you need, when you need to access those communal devices. It's kind of what we're seeing. We believe that we will be able to deliver it when Windows 10 ships, and I hope you would love it. Yes, please.
What happens when your phone is lost or stolen? I go through 2 or 3 a year.
Good question. I was waiting for this question. So thank you so much. So if something will happen with your smart card, what do you do today? Again, how many of you guys have smart cards in your organizations? Some of you. So if user happen to lose their strong credentials, strong proof, so they have two options. They can recover because they have other proofs, other devices that actually can prove identity of this user. If it happens that they lost every single proof that they had, they were swimming in the lake and somehow took all the devices with them. If it's happened, then okay, all bets are off. They need to start again. They need to come to Building 92, Microsoft, show the face, show their documents, and start re-provisioning their identity again. There is no other solutions that we come up with. If you have any ideas, I would love to hear. Okay, so let me walk you very quickly through Passport story. This story is, again, how we provision Passport on enterprise devices. In this particular case, we have, again, Irvin. And Irvin is working in this very magic company called Contoso. And he needs to provision his Azure Active Directory account somehow to be able to get access to Contoso. So I don't know if it's common to your organization, but it's becoming very common in some organization. People receiving some allowances go to Best Buy or whatever place they want, they're buying this device and they're provisioning. So let's ensure that Irvin is capable of doing what he does need to do. First of all, the first question, who owns this device? Who is paying money for this device? And if it's an organization, Irvin would select that it's organizationally owned device. He would be able to join Azure Active Directory right there. We called it UBI experience or out-of-box experience. He will type, I hope it's the last time, his username and password. And after that, we will ask him to create a PIN. And it will be a work PIN. And when Irvin is reading whatever is reading, we're pre-generating the keys for him, we're getting attestation statement for Irvin, we're doing a lot of work that Irvin never would notice. And again, the pin that we're suggesting can be even simple pin, depending on your policy. And we believe that it's not about size. Because we have protections that we need, we believe that policy and pins can be much simpler. And because it's local credentials, it's not something that users will share with their servers, we believe that it's possible to simplify the life. Verification options. We talked about proofing. Users need to prove their identity, and they have multiple options right there integrated with Azure Active Directory. They selected the particular option, and after that we're asking them to create a pin. Please don't worry about ugly color of this dialog. We will change it. So pin complexity, if admin selected different pin complexity, this link is actually available for users. So they can open it and finally see its huge advantage. What policies they need to meet. They don't need to do this, again, try and error every single time I type 6. No, 6 doesn't work. How about uppercase? No, it doesn't work. So we're trying to explain to user what policy they need to meet right there when they're creating their pin. And as soon as they're done, they get access to their desktop. So from now on, when they unlocking their device with this particular pin, it's becoming their unlock gesture. We have access to the keys, and they have single sign-on experiences, not only to Azure Active Directory, services and apps, but if it's hybrid deployment, they can get access to also to their AD services and printers and network shares and anything that they need. Okay, let me try to walk you through deployment scenario a little bit here. So the first case, and it's again, I know that every single customer is different, and our simplifications are Azure AD only people and hybrid people and on-prem people, probably not the reality, but trying to explain what will take for any type of customer deployment to succeed is the goal of those slides. We need two services that need to run in the cloud. And those services is Azure Federation Services and Azure Device Registration Services. Those services are part of Microsoft Azure Active Directory. And those services are available actually today for our Windows Insiders and top customers to validate and to end this scenario. So what will happen, Windows will create those keys. The device is registered. Policy through MDMs pushed to the device. So we know what type of container we need to create, what pin we need to assign to this container. And as soon as the device is registered with device registration service, as you would expect, the public key is moved to Active Directory and associated with the user. So Active Federation services are necessary for us when you have ability to federate with third-party apps in the cloud. And somebody asked me about federation. The federation is done after authentication is completed and registration is done. Then federated services and apps can take advantage of that, because by the end of the day, they will receive SAML token, or they will receive OAuth token from Azure Active Directory and would be able to provide the services to the same strongly authenticated users. Second scenario, we're going in complexity increasing order. So we have hybrid deployment scenario. What I mean by that, some users have Active Directory or identity management on-prem, and some of them have something in the cloud. Being Office 365, or they started to deploy Azure Active Directory. What do they need to do to deploy Microsoft Passport? Almost the same picture as you can see. The additional piece that is required, so the same story. We create those keys, device is registered, policy is pushed to the device. We have proofing method coming from federation services. It can be on-prem or in the cloud. Additional piece is very important piece to keep device properties in sync with your Active Directory computer objects. And there is components that called write back service from Azure Active Directory that's actually going to be deployed and available again for our top customers in a few weeks. So the idea here, it depends on what type of trust you're deploying in your organization. If you're talking about PKI, the only thing is used for device object property and schema. If you're using the key-based trust, it means you don't have PKI in your organization. You password-only organization. And you need to ensure that you would be able to go up with your strong authentication. To be able to accomplish that, we need additional piece. We need something that will be synced back user keys. These public keys that we discussed earlier have to come to AD for AD to be able to authenticate the user. So AD sync right back is device object only if you on PKI third-based trust, and it's user and device only object if you're on key trust. And the last thing, a little more complexity. If you continue to be on-prem only and never think about Azure Active Directory and never want to think about Azure Active Directory, I hope it's not too many customers like that. Can you raise hands for me to figure out how many of you? Even if we will bribe you, nothing will work. Okay. So we understand it. There are some business reasons that you have to stay on-prem, nothing will happen. But we believe that even for you, we need to help you to go from passwords to Microsoft passwords. So what we're planning to do? We're planning in Active Directory ADFS 10 to provide the same capabilities that we will provide in the cloud. You would need to deploy ADFS Server 10 server role on-prem to provide device registration service and the proofing methods that we need. In addition to that, you would need to deploy a few DCs on every single site if you key-based trust person. What I mean by that, Kerberos is changed. We changed Kerberos to be able to work with the keys, not certificates. And to run this code, it's code, you need DCs. So a few DCs need to be deployed on the site to do key-based trust. However, if you PKI people and you don't need key-based trust on your DCs, the only thing that you would need to do is schema update. Okay? Excuse me? Yes, please.
How do you leverage this solution to support system administrator privilege accounts within the organization?
Very good question. So the question is how we will support system privileged accounts that managing this system. So whatever I described can be associated to all your organization or specific accounts in your organization. So for example, if you have high privileged accounts that you're talking about, and you want to ensure that those people never ever will use the passwords, we have additional, again, functionality for those people. We call it device guard, different topic, different presentation. When we absolutely tight what they can run on those systems, but from user authentication, they can use password alone and never use passwords. So you can even go one step further and delete passwords. We called it passwordless mode on the server. And again, there are going to be interesting challenges that we're still going through. But the goal for us to ensure that those high privileged accounts would not be possible to compromise. It's one of the biggest goals that we are trying to accomplish as well. So to sum it up, from password, we have key-based and third-based trust. This table is trying to help you to understand what I was talking for last 15 minutes. Azure Active Directory alone, you don't need anything. You have subscription and third-party MDM or Intune will push policy to your containers. Everything is beautiful. If you're third-based, Azure Active Directory only, you will need, again, AD subscription, PKI infrastructure that you have. If you want attestation, you need to get, again, update your PKI infrastructure to support attestation. And again, third-party MDM and Intunes are available for you. Now, if you're in hybrid mode, you remember when you have on-prem Active Directory and you have some presence in the cloud with identity management in the cloud. For key-based trust, we're talking about, again, simple things, because a lot of functionality we still have in the cloud. So you need subscription, and you need the sync that we discussed. And for key-based, the sync is only pushing down and synchronizing device object property. That's not a big deal. User-based property is a little bigger deal. We understand it. So if you're CERT-based, you don't need too much. Your AD subscription, your PKI infrastructure, all of that can be reused. Or if you need attestation, and I would highly recommend you to use attestation, you need to update your PKI infrastructure. And the last piece, AD on-prem only customers, they would need to have DCs for key-based, as you remember, to run a new Kerberos updated code, and it's a few on the side will be sufficient, and AD Federated Services 10 to provision NGC Microsoft Passport containers. And definitely SCCM solution that will push the policy to those devices if you have on-prem domain joined devices, and Intune or MDM if you have personal devices. For CERT-based only, you don't need DCs on your backend. Change of schema would be sufficient. You need federated services and PKI infrastructure. Okay, I know that it's complex and too many rows and too many questions. Just a moment, we had a question here.
Just the SCCM component, is the SCCM required? Can you push out with other configuration tools or just through GPOs?
So you can do GPOs. What SCCM does for Microsoft Passport, two things. It's pushing the policy and enrolling certificates. For PKI-based customers, what we do, we simplify enormously certificate enrollment. And based on MDMs, all MDMs that we're working with would be able to do the same. If you own PKI Vault, they would be able to push the policy and enroll certificate and manage the lifetime of certificates as well. So we believe it will simplify the whole PKI Vault quite a bit. But if it's not, you don't need PKI capability, cert management, then you're absolutely right. You would be able to substitute the policy pushing through GPO. The question is, what about certificate revocation if MDMs would be able to revoke? Absolutely, because MDM is becoming your array that managing the certificate end-to-end, certificate lifetime. So it's not only revoke, but also renew, refresh, whatever needs to be done with certs can be done. Yes, please, sorry. ADFS is required for three things. First is a proofing message for device and user registration. The second one, if you on-prem, we combine device registration service, the provisioning Microsoft Passport container as part of ADFS package. And the third, ADFS is doing federation. So if you federate it with SAML-based relying party or you're federating with OAuth, you need ADFS to accomplish that. No. You're so welcome. Okay. Yes, please.
Is it just I need federation or it must be ADFS?
It's, maybe I'm wrong, but it's Active Directory Federation Services, ADFS based on Server 10.
So I can't use any or anything.
Most likely you don't. But it's something I need to validate. Okay, so passport gestures. We have plenty, and Windows Hello is probably one of the most convenient and personal and beautiful gestures. We're using Windows Hello biometric authentication, and it's all face, iris, all fingerprints that we support. We believe that it's very convenient and very usable, and I hope users will love it. So I don't know how much you've seen the demos and keynotes and, again, any other things. I will try to do my demo. And again, because of some other things, it might not work. So we're closing the cameras to ensure. So let me switch to the device. And it's 2. Okay, so our Windows Hello Winky, it's the name for these things. The characters that our designers created for us will be looking for you and providing a lot of feedback. It's going through multiple stages. So it's fun, it's actually engaging, but it's also providing a lot of value. And the value is it's telling user what to do. Coming closer because it's camera, so camera cannot see you. Come, again, a little bit far away. If it's too much of you, I see you right now. If it's, again, for fingerprint, any errors, if I'm touching the sensor with the wrong finger, you would see the error messages right there. If sensor, IR sensors that we're using for our face authentication recognition is actually there, and the camera is warming up and we're giving some indicator to the user. So for user to use these things, again, the idea is that they couldn't recognize me, okay. And they would be able to log in right there by looking at the camera or touching the sensor or whatever other biometric device they have. Yes, please. It's so good that you're asking, because I have high-res picture with me. Wonderful. Have I paid you? So this one is high-res picture of the guy that was enrolled here. Let me show you how does it look. And honestly, it looks ugly because we're using IR. And let me show you what IR provides for us. And I have the whole entire slide about security. But let me show you something. And if my device will cooperate, we are doing a lot of self-hosting, so we're updating our builds every single day. Every single day it's a surprise. You don't know what you will get. Oh, okay. So you will get something. Okay, as you can see, we will have different gestures that we're using for Microsoft Passport. And again, if I want to improve my recognition, this one, again, is the way how you will enroll in your system. So let me provide my authentication first, and after that you will see the image, and it's IR image. So I will take this color picture that you're trying to spoof my sensor and trying to show you these things. You see nothing. And it's by design. Because infrared light would not be able to actually get rid of visual light. And because all our solutions, it's not webcam based, so your front-facing camera is not what we're using. We're using IR infrared-based devices. It means that any picture, any video, anything that will have visual light would not be possible to use to spoof this device. And it was critically important for us from security perspective, because to be authenticator, and again, it looks very, very horrifying when you see yourself in that. So, and you would be able to enroll with these things. For ladies in this room, I know that it's horrible. So let me cancel it. But we would, again, I can show you the same experience when you're trying to enroll with, when you're trying to enroll fingerprint as well, for example. So the goal for us to use exactly the same design ideas for all functionality biometric related. So if I will go, I need first to actually authenticate myself. And again, the graphics is not yet final, but let me show you. I can tap on touch sensor multiple times. And again, we're coming with touch sensors, not swipe sensors. And it's incredibly useful and much more easy to actually deal with. And as soon as I will say close, I would be able to lock the system in, touch my sensor, and I would be right there. So in addition to that, let me switch. We have not too much time. If time will permit, I will show you a few more demos, Windows Hello related, but let me ensure that we cover all what I wanted. So, our WinKey. I know that WinKey, you've seen multiple, again, variation, but it's feedback that we're providing to the user. So what I decided to do, because you would not see it all the time, so to show you what are the different stages that our WinKey will support. And sorry for music. Okay, so we hope that it actually will be something that our users will enjoy, despite of the fact that they've been authenticated. Can you imagine that it will happen one day? Okay, so the last point that I want to make, security requirements. For any biometric gesture that we will use on the system, we need to ensure that those requirements are met. And when we're talking about those requirements, we're taking them very seriously. It means our first party and our third party biometric solution have to meet them. Those things are, again, related to concept that I will explain later on Friday. It's called false acceptance rate and false rejection rate, because biometrics doesn't have predictable entropy like pins. So we need to rely on other things to validate the security of biometric solution. The whole biometric science is arriving to the same conclusion. To be secure from biometric standpoint, your false acceptance rate, your uniqueness, or ability for somebody to spoof the device and attacker to pretend to be the real legit user will take 1 to 100,000 different users to be able to do that. So 1 to 100,000 is what false acceptance rate is all about. False rejection rate is your convenience. I'm absolutely legit user, system doesn't recognize me. And I'm like, what is that? My makeup, what is that I did today? So when we trying to ensure that false rejection rate is also very, so users are able to utilize their systems. So imagine if we will go and get false rejection rate very, very high, the system will be incredibly secure. Unfortunately, it would not be usable. So for us, those two things coming together. We want to keep false acceptance rate, as we said, 1 to 100K, and false rejection rate not more than 4%. And there is also the concept of confidence, because it's statistical models that we are building. The confidence level needs to be around 97.5 or higher to reach those goals. To be able to validate those goals, every single biometric vendor that we're working with needs to have a very significant data collection of unique faces. To prove this claim, by the way, they need to have minimum 2,000 unique faces that will be compared, and comparison will give us approximately 4 mil of different comparison. And based on that, running through the algorithm, we would be able to validate those claims, 1 to 100K and 4% of rejection rate. Additional things, anti-spoofing. Anti-spoofing is critically important for us. And for face and iris, we will have additional mechanisms for users to demonstrate the liveness. And again, the ask that we will have on user to, again, move the head right and left easily. And after that, we will know that it's not paper, it's not a picture, it's not 3D mask, it's actually user that's trying to get access to their devices. So liveness detection, anti-spoofing detection is critically important for us to be able to claim that this biometric solution is enterprise-level authentication measure, and we can make it available for Microsoft Passport. And again, to ensure that secure pipe from the sensor to the release credential is happening, we need to integrate our biometric solution with what we call Windows Biometric Framework. Again, more details on next session. And summary. So I hope you had some more information, and we kind of trickling this information to you to keep you interested with Microsoft Passport. So Microsoft Passport, the most important thing, it's not augmentation, it's the replacement of passwords. And the goal for us to make it very convenient and secure. We also apply logic to put the different gestures on top of that, like Windows Hello with face, iris, and fingerprint. And those things we called user gestures that needs to be secure and need to be convenient to be able to provide us access to the keys and have authentication going. You have two-factor oath right there in the box. It's built in. Please use it. Please provide your feedback. We will be interested to improve it, make it even better next time around. Thank you so much for your attention. And I have questions.